Welcome, Neet aspirants. So today we see a small topic from the respiration in plants, that is how efficient is the system, that is respiratory system, in producing the energy. So here if you see the total energy yield, so that is the total energy yield from the one glucose molecule comes to the complete oxidation. So that is 2870 kilojoule. But here the total energy yield from only 38 molecules we are calculating. So from the 38 ATP molecules. So that is, if we calculate the total ATP molecules that is generated from the one molecule of glucose. So in eukaryotic cells, obviously it is 36 ATP molecules are produced because the NADH2 that is produced in the cytoplasm during the glycolysis, so that has to enter into ETS, right? So from the cytoplasm, the NADH2 has to be transported to the mitochondria. So for that it utilizes the 2 ATP. So that's why in commonly the eukaryotic cells we can say that is the 38 molecules, even though it is produced, but it is considered as the 36 ATP molecules are produced in the eukaryotic cells because the 2 ATP molecules are being used from when it is transported from the cytosol to the mitochondrion. And then, so totally here 38 molecules or 38 ATP molecules are produced. So that comes to how much of the energy? So that is 1292 kilojoules of the energy are being produced from 38 ATP molecules. So if we calculate for 1 ATP, then how much energy we are getting? So if we calculate from that is 1 ATP, so that gives how much of the kilojoule? So that yields the 34 kilojoule. So 1 ATP that yields 34 kilojoule of the energy. So now the energy released by one molecule of glucose on complete oxidation, so that is corresponds to, so that is nearly how much of the kilocalorie is produced. So in the complete oxidation of one molecule of the glucose, so that is 2870 kilojoule are being produced. Okay, so when we calculate for this the type of ATP molecules for this 38 ATP molecules, so here energy we are getting is 1292 kilojoule, but what is the total energy we are getting? It is 2870 kilojoule we are getting. So now what is the efficiency here when we compare it? So here just we can say that the efficiency is 45 percentage. The efficiency is the 45%, and this shows it. So here how much of the energy is converted into ATP? So that is 45 percentage of this energy are being converted into ATP, that is 38 ATP molecules. And what happened to this remaining, the energy that is produced? So here this shows that only part of the energy is used to make the ATP, and much of the energy, so that will be like the generated during the respiration, is released in the form of heat. It released in the form of heat. Okay, so now we can say that the efficiency or the efficiency of this respiratory system is the 45 percentage. So we are getting the total energy of 2870 kilojoule, but not all this energy are being converted as a ATP. So how much percentage it is converted as a ATP? That is 45 percentage. That is 1292 kilojoule. So hope you can understand this topic. So for more topics like this, stay connected to Neet Nexus Universe.